Every cloud application needs to support sign-in. While sometimes it seems like a simple function, building a safe and secure sign-in system can be challenging. But I have good news. There's a cloud for that. Hi, I'm Stuart Kwan and I'm a program manager in the identity platform team here at Microsoft. And in the next 15 minutes, I'm going to show you how you can support Microsoft sign-in in your application and get 3 big benefits. Number 1, simplify the sign-in process for your users. Number 2, get direct benefit from the big investments Microsoft is making to secure Microsoft identities online and keep them protected. And number 3, make your application smarter about your users by taking the Microsoft sign-in and using it to access information about the user through the Microsoft Graph. At Microsoft, we've been doing identity for a very long time. Every day, hundreds of millions of people sign into applications using an account from Microsoft. They use personal accounts to sign into Windows, to Outlook.com to do email, to OneDrive to store and share files, to Xbox to play games. They use work and school accounts to sign into Office 365, Microsoft Dynamics, and Microsoft Azure to get work done. And Microsoft makes big investments to ensure the enterprise-grade, worldwide availability, reliability, performance, and security of this system so people can confidently work and play in the cloud. There's good news. You can use Microsoft Identities with your application as well. In fact, let's take a quick look at a simple application which uses Microsoft Identity for sign-in and see what the end user experience would be like. Here I have a stock ASP.NET template, but I've added Microsoft sign-in. Up here in the top right-hand corner, we can see the Microsoft icon, and that's how we signal to the user that this is how they can sign in with their Microsoft account. If I go ahead and I click that, I land on the sign-in screen, and let's use a personal account to sign in. When I put the personal account in fact, I've already signed in elsewhere on this PC with this personal account, so I don't have to type in another password. I'm automatically signed in. Similarly, if I sign out and I choose to sign in with a work account, then I'm quickly signed into the application again. It's as simple as that. If you support Microsoft Identities for your application, not only do you get that simplified sign-in that I just showed you, but also under the covers, Microsoft is doing a huge amount to protect your users online. We implement things like strong authentication through multi-factor authentication methods, something that if you've ever tried to integrate this into your own sign-in system, you know this isn't a straightforward thing. We also do billions of authentications every day, and we take that traffic and we funnel it to specially trained, and we use it to train machine learning algorithms to look for patterns in sign-in and look for anomalies in sign-in requests so that we can stop account compromises before they happen. When users' names and passwords are given away on the internet, we scour paste bins looking for those lost names and passwords and comparing them against the user accounts in our system so that we can tell people if we think their password has been compromised. Similarly, we have a big effort at Microsoft to do things like crack botnets and find infected machines. We take the IP addresses of those machines and we feed them into the account system so that we can prevent sign-ins from coming from those infected machines. And we do a whole bunch more. Now these are things you probably think, wow, it would be great if I could do those in my application, but I'll never have the time or the expertise to do it. Well, at Microsoft, we can't afford not to have the time and expertise to do this to support our cloud businesses, and you can get direct benefit from that without paying any money to do so just by accepting Microsoft sign-ins in your app. Finally, you can enrich the experience in your application by taking that Microsoft sign-in and using it to access more information about the user through the Microsoft Graph. And I'm going to demonstrate that a little bit later in this video. So how do you integrate an application with Microsoft Identities? It's very, very simple. First thing you need to do is register your application with Microsoft. The second thing that you need to do is write code that sends OpenID Connect or OAuth 2 requests to Microsoft and then handles the responses. And it's really as simple as that. Microsoft Identities work with web applications, PC applications, and mobile applications. We provide open source libraries in a variety of languages to help accelerate your development and reduce the amount of security-related code that you need to write yourself. If you're familiar with Azure AD sign-in, what's new here is the ability to sign in both personal account users and work account users with a single request. This is thanks to recent developments in bringing together the Microsoft personal account system and the Azure Active Directory work account system into a single endpoint for developers to use. We call this the Azure AD V2 endpoint. Now, there are some differences between Azure AD and the V2 endpoint in how you register your application, how the protocols are implemented, and the libraries that you use in your application. Also, the V2 endpoint does not yet support all of the scenarios supported by Azure AD, but you can learn about this in our developer guide, which I'll be pointing to a little bit later. So let's do a demo now of a very simple registration and OpenID Connect flow. The very first thing that we need to do is register our application. And to do that, we go to the application registration portal at apps.dev.microsoft.com. I encourage you to follow along at home and do all the steps that I'm doing so you can see how simple this is. I'm going to go ahead and I'm going to click to add a new application. And let's just call this thing Test Application 2. When I register an application, I get an important piece of information back called an application ID. The application ID is what I use in the code to identify my application to Microsoft. Here's that application ID. I'm going to go ahead and copy it because we're going to use that again later in the demo. Now, again, the system works for both web, mobile, and PC applications, but for this example, let's build a web application. I'm going to add a platform. I'm going to choose the web platform. And then I need to provide one more important piece of information about this application. It's this thing called the redirect URI. This is where it's safe to send back tokens about the user after they've signed in. So for this demo, I'm going to use HTTPS localhost. And with that, I can save the app, and I've completed my registration. Now what I'm going to do is show you a basic OpenID Connect request. I'm going to hand code the request to see how simple it is. However, a very important note. I don't recommend that you hand code requests in your production applications unless you're an expert in all of the security considerations in the protocol. That's why we produce open source libraries, so that you don't have to learn all of that. Now, to do this basic request that I'm going to send, I'm going to open my trusty notepad, and I'm going to build a URL, because an OpenID Connect request is just a URL. At the very beginning of the URL is the Azure AD V2 endpoint. That's where we're going to send our request. The parameters of the sign-in request are just query string parameters in the URL. The first one is the client ID, and here we're going to enter that copy and pasted client ID that we got from the application registration portal. The second parameter is the scope parameter. The scope parameter is the way that your application requests information or permissions from the user. In this case, we see we're using the OpenID protocol, and that we want profile information about the user when the user signs in. The response type tells us how we're going to get back that information from the request in the response. In this case, we're asking for a thing called an ID token. It's going to have that user profile information in it. And finally, we're going to send it to the redirect URI, which we indicated earlier was localhost. And we finally need to provide this thing called a nonce. A nonce is a big random number to be used once that matches requests and response in the protocol to mitigate against things like replay attacks. So I need to put a big random number here. I'm going to use my random number generator known as mashing my fingers on the keyboard. Okay, so I've got a random number. I've got everything I need. Let's go ahead and take this URL, and we're going to assemble it into one big string. And we're going to take a copy of that and go to the browser, and we're going to paste it in. All right, we're ready to send our first OpenID Connect request. We send that now. And as you can see, we're signing into Test Application 2, the app that we registered earlier. And since I've already signed in with my work account, I'm going to go ahead and click to sign in and use that account again. Now, the first time I visit this application, I have to consent to using my Microsoft identity with the application. And here you can see I'm asked to consent to send my basic profile information to the app. That's what we indicated in the scope, that we wanted profile information about the user. If I click accept, then the sign-in will be completed. Now, I actually don't have anything listening on localhost on this PC, so we're going to get a not found in the browser, but the response is in the URL. Let's go ahead and we'll copy that URL, put it back into our trusty notepad, and we'll see what we've got. And when we look at it, what we find is, look at this. Here in the fragment is the ID token that we requested. Let's go ahead and break that ID token out so that we can examine it more carefully. The ID token is a base 64 encoded JSON web token. I happen to have a little decoder here that's going to let us look inside this thing. And here we can see the information that was returned about the user from the sign-in request. We've got things like the display name of the user, we've got things like a preferred sign-in name, we've got things like this subject field, which is a unique number that represents this user, an identifier that is rename safe and won't change if I change my name, if I change my preferred username. It's safe to use as a security identifier or say a key into a database. But that's the basic profile information that comes back when I do that OpenID Connect sign-in request. And it's as simple as that. Now remember, we don't recommend that you hand code the protocol in your app unless you understand all of the security considerations of the protocol. For example, in this particular case, the response came back in the query, in the URL, in the query string. And query strings get captured in things like browser history, they get captured in things like proxies that might be logging requests, and that might not be the right thing for your application. That's why we provide libraries, and our libraries use the right profile of the protocol given the scenario for your application so that you don't have to worry about things like this. In fact, let's take a quick look at the code of the sample application I showed earlier. It's an ASP.NET MVC application, and it's using our OWIN OpenID Connect middleware. The OWIN OpenID Connect middleware will automatically help you with sending requests and handling responses from the identity system. Here, the highlighted code, you can see I'm initializing the middleware, and I'm providing a lot of those parameters that you saw earlier when we hand created a request. Once the middleware is initialized, it's very simple to issue a command to send a request, and then when the response comes back, it's handled automatically by the middleware. The middleware will check the signature on the token, which I didn't show you earlier. This is really important. The token has a signature that is a cryptographic signature signed by keys from the Azure AD v2 endpoint, and it's the way that you verify that this information came back from a source that you trust. The middleware automatically handles that and then takes the profile information out of the token and presents it to you in a .NET object model. So we do recommend that you look at our middleware for a variety of languages when you're building a production application. I've also implemented or integrated this sample application with the Microsoft Graph. The Microsoft Graph is a REST API that lets you take a Microsoft identity and then programmatically access information and calculated insights about that identity. So for example, you can ask to see a user's calendar, their email, their contacts, and then we also infer relationships like who's working with who are related people to who, and we can provide that information back to you. The user gets to decide what kind of information that they share, so you can just ask for the pieces that you want. And this is stuff that you're not going to get if a user just gives you a name and password. These are things that you can use to make your application smarter. Let's go ahead and take a look at the sample application again at the beginning of the video where I signed in. I've actually added the capability to see related people. This is a beta API in the Microsoft Graph where we infer information about people interacting with the system and say, well, these people appear to be related to these other people. I'm going to go ahead and click that tab, and I haven't given this application permission yet to see related people, and if I want to give that permission, I need to click here. Now this is a new feature that we have in the v2 endpoint that we call dynamic consent, where an application can ask for the permission that it wants at runtime, on the fly, in the context of the thing that it wants to do. This is just like when you're using your mobile phone and you've installed an app, and the app now wants to use the camera to take a picture or access your location, and it asks for it in the moment so that the user doesn't have to give all that permission up front when they're using the application. So here I'm going to go ahead and I'm going to click to grant that access to see related people. That brings me back to the Microsoft sign-in page where, again, I see the list of scopes that the application is asking for, including the ability to read relevant people. I'm going to go ahead and accept that. Under the covers, my application is receiving a token that it can use with the right permissions in it to call the Microsoft Graph on the Related People API and then display that here on the application screen. Now, I don't do a lot in my test tenant with my test users, so there's not much going on here to show relationships between people. But here you can see the system does know about few people that are interacting in that tenant, how they're interacting with each other, whether they're related in the directory or they've had some communication history with each other, and then details like their names and their email names that you might be able to take advantage of in your application to try to find other relationships between people using your app, or that you might want to invite to certain features based on the way people are working with each other. So you can see how you could use the Microsoft Graph to make your application smarter. The way that I got that token in the code is actually using a new client library that we call the Microsoft Authentication Library. If you're familiar with Azure AD, we have a thing called the Active Directory Authentication Library, or ADAL. MSAL is the analogous or successor to ADAL, but for the V2 endpoint. So I use that MSAL code to get that access token so that I could access the Microsoft Graph, regardless if the user was a work user or a personal user. As of build, we have the MSAL library for .NET available in preview, and we'll be releasing more versions in other platforms as time goes on. That's it. If you support Microsoft Identities in your application, you can simplify the sign-in process. Your users don't need to remember more passwords. You don't need to protect more passwords. And they can get single sign-on between Microsoft applications, Windows, and your applications. Microsoft makes huge investments to protect users online, and your applications can directly benefit from that without you having to gain any of the expertise or spend any of the time doing all of that work. Finally, if you sign a user in with a Microsoft identity, you can use that to programmatically access information and calculated insights about those users and make your application smarter. And that's not something you're going to get if people are just signing into your application with a name and a password. Finally, integration is simple. All it takes is industry standard protocols and open source libraries. To get started, visit our dev guide at aka.ms/aadv2. We'd also love to hear from you. You can email us at aadintegrate@microsoft.com or catch us on Twitter @AzureAD. We monitor Stack Overflow for the tag Azure Active Directory. Now remember, when it comes to identity, there's a cloud for that. Thanks very much for watching.